In today's video, I'm going to show you something I'm genuinely proud of, an 8x8 RGB LED matrix that I designed completely from scratch and had professionally assembled in a real factory. And the cool part? You can chain multiple modules together and control everything as if it was one giant display. This was my first time using PCB assembly services, so honestly, I wasn't sure if it was going to work. But let me show you exactly how I designed it, why it works, and what I learned along the way so you can make your own LED matrix too. This matrix is built around a special LED you probably already know, the WS2A12B. If you don't, here's a short explanation. The WS2A12B is a RGB LED with a tiny integrated circuit inside. That chip is the reason these LEDs are so fun. You can control the color and brightness of every single LED individually, using just one data pin from your microcontroller, like Arduino, ESP32, Raspberry Pi, whenever you want. Every LED has 4 pins, 5V, G and D, data in and data out. And the data out of one LED can be connected to the data in of the next one, creating a chain that allows you to send instructions down the line. The protocol they use for communication is called NZR, but you don't need to dive into the deep theory to use it. Libraries like the Arduino Adafruit NeoPixel hide all the complexity for you. This daisy chain data system is the core idea behind the matrix. Once you understand that, the rest of the design becomes much easier. Alright, let's talk about the actual module I built. This whole project started because I wanted a custom LED matrix that I could expand later. Something modular, simple and clean. So I opened KiCad and started working on the schematic. The matrix uses 64 WS2A12Bs arranged in rows and columns so wiring stays easy. And for each LED, I added a 100 nanofarad capacitor right next to it. You may be thinking, why that capacitor? Because these special LEDs can create tiny current spikes every time they switch colors. Without capacitors, these spikes can cause brightness flickering or even damage the LEDs over time. So the standard practice is one 100 nanofarad capacitor per LED placed as close as possible. Now, something you'll notice is that I didn't add a current limiting resistor to the circuit. That is intentional. You don't need one. The LEDs have an internal constant current driver, so the LED regulates itself. After laying out the schematic, I added a simple 4-pin connector, 5V GND data in and data out, that makes it easy to chain multiple modules together. Once the schematic was done, I knew I wanted to manufacture the PCB and let the factory assemble all the LEDs for me. And speaking of manufacturing, this is a perfect moment to talk about today's sponsor, GLC PCB, the company I trusted to build this project. If you are a maker like me, you know how many hours a project can take. Testing circuits, printing parts, writing code, etc. So having a partner that can handle PCB fabrication and assembly is honestly a lifesaver. For this project, all I had to do was upload my Gerber files to GLC PCB Instant Code tool, choose 2 layers, black PCB color, and select PCB assembly. And right there on the screen, it showed me the price, the parts list, and when everything would be finished. Super quick and super simple. A few days later, a box showed up at my door and inside were 5 fully assembled LED matrix modules. I remember opening that box and thinking if it would work. This was my first time using an assembly service, so the excitement was mixed with a bit of fear, but everything looked perfect. Clean soldering, neatly aligned LEDs, the whole thing just looked like a real product. If you want to try the same experience, the project files are linked in the description. You can upload them to GLC PCB, pick the assembly option, and they'll take care of everything. Huge thank you to GLC PCB for sponsoring this video and supporting my projects. Now let's get back to the build. Once the schematics was done, I went straight into the PCB editor. The PCB needed to handle a lot of current. A full 8x8 matrix at maximum brightness can draw around 5 amps. That is a lot for a compact board, but I didn't want thick, giant traces everywhere because that would make the PCB huge. So I made a design decision. I would limit the maximum recommended brightness. At 50% brightness, the matrix draw about 2 amps, which is manageable with 0.8mm power traces. On the other hand, data traces only need around 0.3mm, as they carry few amounts of current. Another thing to keep in mind is that if you are making a project like this, don't power it directly from your Arduino 5V pin unless you set the brightness to low values. Use an external 5V supply for safety. With all that planned out, I routed the board, added the labels and logo, and generated the Gerber files, and at this point the project existed only on my computer. I had no idea if it would work, so I packed the project files and sent them to be assembled. So the PCBs arrived, everything looked great, but my mind instantly went to, does it actually work? Only one way to find out. I wired up the first board using an Arduino and set up a quick test animation using the Adafruit NeoPixel library. When I plugged it and saw the LEDs come to life, man, that was a good moment. This is something I love about electronics. You think about an idea, sketch it, design it, fight with the software, hope you didn't miss a trace, and one day a project that existed only in your head suddenly becomes a real physical thing sitting in front of you, doing exactly what you imagined. That feeling never gets old. And the best part is that you can do it too. You can invent anything you set your mind to. And now that the first test worked, I chainned the modules together and once again everything worked perfectly. The matrix behaved like a single giant panel just like I planned. To control the matrix, the code is actually very simple. I used an Arduino Uno for the demo you saw earlier, and the whole thing relies on the Adafruit NeoPixel library. Just tell the library how many LEDs you have and which pin you are using, and then you can set the color of every single pixel. I uploaded the exact code I used plus all the manufacturer files in the GitHub repository linked below. So if you want to build the same module or modify it, everything is waiting for you there. Upload the sketch to your Arduino, power the board, and the matrix should spring to life. And that's it for today's project. I hope this video inspired you to design something of your own. You don't have to start big, just build something. The moment you see a PCB you designed show up at your door, fully assembled and working, it's an amazing feeling. You can invent anything you set your mind to. You just need to start. If you enjoyed this video, make sure to subscribe so you don't miss my next projects. And before you go, check out the video popping up on your screen. I'm sure it will spark your next idea. Thanks for watching and I'll see you in the next one.